Hi and welcome to John's Maths book. In this video we're going to be looking at graphing sine and cosine functions. If you like the video then please hit the like button and I'd be delighted and honoured if you'd subscribe to the channel. Without further ado, let's go over to the whiteboard. If we look at our unit circle on the left, we can see that each point has the coordinates cosine theta, sine theta, where cosine theta is the x-coordinate and sine theta is the y-coordinate. For more details on this, watch the video I created describing the unit circle. So if we first look at y is equal to sine theta, if we look at our unit circle, we can see that the values of y extend from -1 through to 1. So we need to be looking at this value here on the unit circle and this value here. This is known as the range. If we now look at y is equal to cosine theta, this time we need to look at the x-coordinates. As we can see, y again extends from -1 through to 1. So we need to look at this value here and this value here on the unit circle. These functions are periodic because their values repeat. The period of the functions cosine and sine is 2 pi radians. Once we've gone through 2 pi radians, we return to the beginning and the values start to repeat. And so sine theta is equal to the sine of theta plus 2 pi. And similarly, cosine theta is equal to cosine theta plus 2 pi. So that's saying, for example, that the sine of 30 degrees is equal to the sine of 30 plus 360. So the sine of 30 degrees is a half, and the sine of 390 degrees, so once around the circle and another 30 degrees, so this point here, is also equal to a half. Similarly, if we look at something like cosine of 60 degrees, that is the same as cosine of 60 degrees plus 360. So again, we go once around the unit circle and we travel up 60 degrees to this point here, and we find that the cosine of 60 is a half, and that equals to the cosine of 60 plus 360, which is 420 degrees, which is also equal to a half. If we now look at sketching the graph of y is equal to sine theta, we can see that when theta is 0, y is also 0. So the graph will start here. If we then move around the unit circle, we can see that when y is equal to a half, theta is 30 degrees or pi by 6. So it will be somewhere around here. And then if we move around even further, let's go to 90 degrees on the unit circle. We can see that at 90 degrees, the sine of 90 degrees is 1. So 90 degrees is pi by 2, so we'll be somewhere here. If we go even further around the unit circle and we get to 150 degrees or 5 pi by 6, we can see that the sine of 150 degrees is also a half. So we come back down. And then at 180 degrees, the sine of 180 degrees is 0 again. So if we plot from 0 to 180 degrees, we have something like this. If we then continue beyond 180 degrees, so that's values of theta from 180 degrees to 360 degrees or 2 pi, we can see that the values of sine theta become negative. So at 3 pi by 2 or 270 degrees, the value of sine theta is -1. So if we continue to plot the sine curve and we return to 2 pi or 360 degrees, we see that the sine function is periodic. So from 0 to 2 pi is one period. So if we look at the maximum and minimum values of y, so there's the maximum and there's the minimum. We see this point here. This is known as the amplitude. So for this graph of sine, the amplitude is equal to 1. So y equals sine theta is the same as saying y is equal to 1 times sine theta, where 1 there is the amplitude. Or we can say y is equal to a times sine theta. So if we now change the function from y is equal to sine theta to y is equal to 3 times sine theta, we can see that the amplitude is now 3. So the graph will extend from -3, this point here on the y-axis, to +3 on the y-axis. So now if we look at the graph of y is equal to -3 sine theta, we note that the coefficient in front of sine theta is now negative. So the effect of this is that the graph is reflected across the x-axis. So in the case of y is equal to a times sine theta, the amplitude is equal to the modulus of a, so the positive value of a. We should note here that as the amplitude or the coefficient a increases, the graph will get stretched vertically upwards. If we now want to change the period of the function, we multiply the angle theta by a constant. So in this case, we have y is equal to sine 2 theta. So the period in this case goes from 0 to pi. In our previous example where we had y is equal to sine theta, the period went from 0 to 2 pi. So where we have a function y is equal to sine a times theta, the period is determined by 2 pi divided by a. If we now look at the graph of y equals cos theta and we try and sketch it, we see, looking at the unit circle, at 0 degrees theta, the value of cos theta is 1. So we start here. And then at pi by 3 or 60 degrees, and then it crosses the x-axis at pi by 2 or 90 degrees. So at that point, cos theta is 0. It then falls again till it bottoms out at y is equal to -1, and that's at pi radians or 180 degrees here. It then rises again through 270 degrees or 3 pi by 2 radians, where it cuts the x-axis at 0, and then continues to rise until it gets to 2 pi, where its value is 1 again. And then the graph of y equals cos theta repeats itself. So that again is one period. So period definition, amplitude definition that we saw before with sine applies to cos as well. In addition, the transformations relating to amplitude and period applied to cos in the same way as it did to sine. So now let's see if we can graph the function y is equal to 5 times sine 4 theta. So the first thing we can look at is finding the amplitude of the function. Now we know that when we have a function in the form of y is equal to a sine b theta, the amplitude is a, or the coefficient. So in this case, the amplitude we have is 5. So let's mark this on our graph. So we'll put our graph scale on the y-axis. That'll be 5, 2.5, minus 2.5, and minus 5. And for the period, we know is equal to 2 pi divided by b, where b is the value that's multiplied by theta. So in this case, the period is 2 pi by 4, which is pi by 2, or 90 degrees. So let's add these values to our x-axis. So we know the length of the period is pi by 2. So halfway will be pi by 4. Quarter of the way will be pi by 8. And 3/4 of the way will be 3 pi by 8. So we know that this graph will reach its peak amplitude at pi by 8 and then fall to -5 by 3 pi by 8 and will cut the axis at pi by 4. We also know that it'll start at 0. So let's quickly plot this. And there we have it. Y is equal to 5 sine 4 theta.